Okay. So sorry. I'm like, okay, let's see. Good afternoon, Melissa. Hello, Rachel. Good afternoon, Isabella. Hello, Amanda. Good afternoon, Farina. Sorry I'm late, everybody. Still, I'm catching up myself or my breath or whatever. Hang on. Wait, we are recording. Okay. Oh, I don't want that. Hold on. Yes, okay. Pardon me. It's still getting on spazzed here. Oh. Okay, hello. All right, we blah, 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 blah. Oh, people still coming. Even if it's such a relief when someone's later than that. Okay, hold on. Okay. Okay, we have much to do today as always, blah, blah, blah. I want to get back to this wave equation. I love the wave equation. We are getting back to the wave equation momentarily. Spent 2 days deriving it, which is like a lot, but I always ends up happening. I always think it's worth it. I'll explain why today. But today we don't want to derive it anymore. We want to like talk about it, analyze it, use it, whatever. I will say also that even though there's always, there's always a lot to do in this course that I want to do, and never enough time. But if we got hit by a truck, I don't mean to say, if we all had to end like this week, I at least would want to get through the wave equation and through Doppler effect, which I know you're doing in lab, but I love the Doppler effect. And I mean, if nothing else, I want you to have the Doppler effect before we're done. But anyway, so we're going to get back to this wave equation. A couple of logistical announcements. So you still don't have, I mean, there's no major outstanding new assignment or anything like that, and we're going to hold it that way for a bit. I mean, we're going to keep it that way for a bit, but hopefully, I think I did a little catching up this weekend. Hopefully, for the most part, anything and everything that anybody has turned in, for the most part, hopefully has come back now, and hopefully somewhat self-explanatory, but just a couple of items, like on that thing where I'm setting, where with some of you, you're still waiting for me to set up a partner. I'm actually almost done with that. I have an Excel spreadsheet going, I just want you to know it's not lost and forgotten. And when I finally do give you a partner, it won't be that big of a deal, but it is optional, but I'm almost set coordinating things there. With test corrections, exam corrections, a lot of you did them. A lot of you have now finally gotten them back. I'm pleased. I think it really actually helped me a lot to see how you corrected your exams. Hopefully it helped you with some points back. Someone's still here. Pardon me. Again, it's like other homeworks where, the statute of limitations has not run out. Like, it's still possible to do them if you wish. If there's, I guess I'll say this came up in the other class. In a couple of cases, and these files are getting big, the test corrections, like I did ask, and most of you did do, I appreciate, like I could only, it's sort of hard to do test corrections and to grade them. And so it really makes it only possible if you actually re-include or reattach a copy of your original graded exam. I mean, obviously I have that on file, but it really does make it possible to do only if you give it all to me as one file. But in some cases that meant the file was so large or so complex that for some reason I couldn't load it. So in some cases with some of you, I said, can you please like try to reload this file again? It's not personal. It's not that anybody did anything wrong. And it's not, and you're certainly not going to be marked late or anything like that. So please, if I did say that, don't take it personally or don't overthink it. Just try it again. But I do need, either an attachment or an inclusion of the original test corrections. If you have any personal issue with your exam or your exam corrections, it's still, again, we can make an appointment and talk personally. That's like the best way to do it at this point, whether it's a phone appointment or what. Don't worry about the clock running out. It won't, as long as you don't forget. I won't forget. Why am I saying all of this? The one reason I'm saying all this about exam corrections, I mean, now that I've gone, so in many cases with you guys, I went through the exam and then I went through your second version, and a lot is revealed in the second version. So the one thing that I now have noticed in both sections of this, and I'm saying this now basically to ask you to remind me before the semester is over, one place where people lost points in the first instance and then possibly might not have been able to read my handwriting or whatever, but then people still lost points even in the exam corrections. And I think even in good faith, there's one area where people even tried to read my comments, even tried to honor them, but then still, I think in good faith, did not understand what my criticism was or something, is in the area of free body diagrams. Like, what I think at this point is that there is actual legitimate, honest confusion or misunderstanding about free body diagrams, or at least component diagrams versus pure diagrams, or something about free body diagrams that seems to be underlying in both sections people's work. Now, this is not an issue of fault or anything like that. But free body diagrams are really fundamental. And if there's a misunderstanding of free body diagrams, it probably means there is some kind of fundamental misunderstanding of something that's only going to make matters worse for y'all as y'all continue as physicists or scientists. So I really think it's incumbent on me to make sure to straighten that out with you guys before the semester's over. Of course, it's like a physics 1 thing. So it's like a little, so I'm saying all this right now to say, I can't do it today in class. I kind of want to stick with the momentum with the wave equation. But I'm also afraid if I keep doing that, I'm going to postpone it forever. So what I'm saying to all of you, especially if you lost points on the free body diagram, and then I still took off points on the exam correction, and you probably, in many cases, you probably were honestly trying to correct, but you really don't know what it is I'm asking or something. Like, I want to straighten this out as a group with all of you. I want to talk about free body diagrams at some point. I don't want to do it today. It might only be a 10-minute thing, but if I'm not careful, it could turn into a 25-minute thing. So I'm kind of asking you guys to have in the back of your mind to remember at some point, to remind me to go back to free body diagrams. And especially if you feel like there's still points that you are just not being able to get back because you just still don't understand what I'm asking. I'll try to turn this into some kind of way to get points. Some kind of way to get these points back for everybody. And if nothing else, to incentivize you to remind me. So please remind me at some point. It would be irresponsible of me to let you all graduate 2 semesters of physics without straightening out this free body diagram thing. Again, it is not fault. You didn't learn it in this semester. You learned it last semester. If anything, it's possibly the fault of the teacher that you had last semester, which was probably me. So this is, so I need to rectify this somewhere, somehow. So again, just remind me at some point, please, even privately or publicly, whatever. And again, I'll figure out a way to do points for it, but also I still want to fix that other side. Anyway, all right, so that's that. That's one thing, free body diagrams. The other thing is, it had to do with points and grades. So I also want to say the following, because it came up in the last section earlier this morning. Especially when grades are involved and exam corrections come back or whatever, there's sometimes people send me, what do you call it, direct chats or private chats, while I'm teaching, right? And sometimes, because I'm a spazzy guy, I screech to a halt when I see the direct message, and then I stop and respond to it or whatever. And of course, if it's actually private, I try not to talk about it or whatever, but sort of everybody can see me grind to a halt and see me get all off kilter. Which then means that sometimes, and it might be, and it's often a private message that very much should be a private message. It might be about the person's grade or something like that. what I want to say now, right now, like this is not happening right now. Nobody has sent me a private message like in the last 5 minutes. This is so nobody should feel criticized by what I'm about to say. What I want to say is I realize that sometimes when people send me a direct message and then I grind to a halt or I look all distracted or I look like I'm off topic for 5 minutes or something, I look like I'm not teaching for 5 minutes, that can discourage people. Like I tend to get private messages now from people that say like, please don't stop what you're doing. I don't mean to distract the class, but I just want you to know for later that you da who da he da, or like that I can't come to class because like my elephant is sick and like the only person that knows how to feed my elephant is my housekeeper, like whatever. So I think many of you in good faith will send me a thing like that also because it's hard to get me an email. But then like you don't want the whole, you understand that you don't want the whole world to stop just because you had this private thing, and you certainly don't want me to embarrass you publicly or something like that. And I get all that. But what I worry is that then people are discouraged from sending me the private messages because they're so afraid of like stopping the class on a dime and stuff. So here's what I want to say right now, even before it happens. Like, that's on me, not on you guys. Like if I choose to read a private message in the middle of class and I deem it like worthy of a response from me, and I choose to like stop what I'm doing and respond to that, that's a decision I'm making. You're not forcing me to do that. I could ignore like, first of all, I could choose just not even to look in the chat while I'm talking. And sometimes if I get enough momentum, I totally forget and I don't look in the chat. Or I could choose to look in the chat and read it and be like, okay, this is like way too personal or like way too complicated. I can't deal with this right now. And I could keep teaching, right? Like so if I grind to a halt and decide to stop everything I'm doing to respond to your message right then, that's a decision I'm making, not anything you forced me to do. And hopefully I'm never like mentioning a person's name or doing anything like that. But if I do that, that's a decision I'm making, and I'll tell you in a moment why I make that decision. I do not want that to discourage people from using the private chat for this purpose. Like basically what I'm saying is, I used to worry about this a lot at the beginning of the pandemic and all, but at this point, I cannot think of an instance where anybody in this room like abused the private chat privilege. Like, I don't even know exactly what that would mean, but I don't think anything that anybody has sent me in the private chat has been inappropriate or badly timed or unfair or anything like that. And especially given that it is like that sometimes I'm bad about emails. This is your time. This is our time that we get together. This is your access to me. You guys have been using the private chat very responsibly. And 90% of the time that I stop on a dime to deal with a private chat, whether it's like someone's asking, like, I don't understand, like how you did the exam corrections and did your grades like this, like I feel like I should have gotten a higher grade or whatever. Or if it's someone saying this thing happened in my family and I can't come to class tomorrow or blah, blah. The reason I'm choosing to stop and respond to that right then is not only because I think it is worthy, but also because I'm very afraid that I'll forget later or like leave you hanging. And that's like doubly bad to do that. So if I stop on a dime for a private chat, again, I hope I've never embarrassed anybody or like and no one's complained about this. This is all I'm saying this in my head. I've just noticed that people seem like nervous about stopping me. And then if I do stop, I feel bad for that person that I stopped. But I need you all to know, like, oh, sorry, it's actually happening right now. Okay. And I'm going to ignore it for a minute, but like, I need you all to know that I would and someone's here. Hold on a second. Zoom is all weird and the pandemic is all weird and everything is weird and I'm a weird guy anyway. But here's the thing. I would much rather think that over the course of this semester, each one of you got at least a minute and a half where you actually needed something and you felt I was there to respond to your need in that minute and a half. And then as a sacrifice, you had to be bored for 5 minutes, like, or somewhere where I was dealing with someone else. Like, I would rather each one of you think that in the moment you actually need something and that you're actually reaching out, that you get at least an acknowledgement from me. I would rather have that each one of you have that minute and a half that you need when you need it, and have a little bit of boredom and spasticity or awkwardness for the other 45 minutes for the rest of you, then for me always to be teaching to all of you and therefore to be teaching to none of you. if that makes sense. Like, it is much more about me trying to connect with each of you as an individual, even often at the sacrifice of a group, than me trying to connect to a whole group and therefore connecting to no one. Like, if we were in person, this will be a whole different dynamic, but it is very hard for each one of you to get what you need or to feel like you're actually in this class, except or unless at the moment that you actually have something burning on your brain to feel like I'm there and hearing it. Like, to put a whole other way, it at first I thought the whole private chat thing was freakish and weird, but now I realize it's probably one of the few virtues of Zoom that we don't have in a regular classroom. This is a long way of saying when the spirit moves you. I mean, and again, if I thought you guys weren't being respectful about it, or I thought you were abusing it, it would be a whole other conversation. But if suddenly the spirit moves you and you need something from me, since I also know that you'll get it, like, the worst thing I'll do is say, like, okay, let's make an appointment about this. Like, call me on my cell and we'll make a phone appointment. That's like the biggest blow. And then I'll mean that. I'd much rather that than be worried that people are not reaching me during with email or blah, 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 blah. Like, this is your time. It is. And you don't have to cater to my needs or to your colleagues' needs as such. You have to get your needs met. If that makes any sense. And also, again, anytime I get a private chat from one of you, it may not prove that you're totally absorbing all of the material at that moment, but at least it sort of proves that you're there, right? Like, at least I know that you're sort of in a classroom zone and sort of like using me as a teacher. So I would rather 48 individual versions of that. Okay, I'm going to keep saying, I mean, you get my point, but please, 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 I think people are using the private chat correctly. I think you should not be embarrassed or worried. And we all know I'm spaz. Like, I am spazzy about these things, and we all know I can't multitask. So yeah, I'll spaz out for a minute when I get a direct message, but it's so plausible that once I'm rolling the material, I'll like overlook them or forget them anyway. It's not your job to compensate for that. So all which is say, if you have an issue about your grade, or I'm still owing you a document, which is the case in some of your cases, like I still do owe some people something, you can use the private chat to remind me or set up an appointment. And even if I stop right then, I won't mention your name. And I'm not angry or anything like that. It's just one more piece of evidence that at least one person in the room is like actually engaging and getting something out of this, right? Okay, so that's again, nothing like that even happened today at all in this class. It sort of happened in the other class. So I'm saying it now before anybody feels embarrassed or anything. In fact, I'm looking at the private chat and I think, okay, right, all right. Oh, okay. So now, okay, in fact, okay, so there is a question in private chat. I'm not going to mention anybody's names, but there is a little confusion about something I do want to address now. So there's like these two optional assignments out there, or have been out there: the exam correction and the like use a partner to redo something, which was called like plan, prepared, partner, something. But there does seem to be confusion about these. On the one hand, I will totally still accept either or both from all of you. I will. So don't worry about I mean, the deadlines are for a purpose and to keep us all organized, but I will accept exam corrections still from people. If it takes long enough, maybe I won't give as many points, whatever, that's my prerogative, but I will take exam corrections, and I will take that versions of that other more weird assignment where you're supposed to partner up and help somebody or partner up and be helped. But they are two very different things, and there does seem to be confusion about this. So with the exam corrections, yes, I'll take them, but that's something you do on your own. That has nothing to do with a partner or anything, the exam corrections. That is literally about you trying to show that you saw my feedback on the exam and you've improved your understanding. The exam correction, so let me, and also please, if you have confusion, but don't forget about the videos, and please do watch them when you think, because there are certain things I feel like I'm repeating a lot and at the risk of boring certain people. So on the exam correction, I will still take them, and I won't be upset that they're late or anything like that. But that is something that you do on your own, and you do, I mean, you can get help. But I'm not looking for you to be partnered up or anything like that. You just like do them with whatever help you need to get. But on the exam correction, let me also make clear what the rule is about it. In order to get back points on any particular, you don't have to redo the whole exam, but any problem, any part of the exam that you want points back, you've got to redo the whole problem. And I want to make this clear to everybody. You can't just, I mean, this came up. You can't just redo the parts you got wrong. you can't say to me, I mean, you can do it if you want, but you don't like give me a document that says like refer to part A on my original for this work, refer to part B, but here, okay, I know I missed points here, so here's the no, 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 no. That is too hard for me to like, that puts way too much onus on me, number one, but also number two, it does not show, that's not a corrected exam or an improved exam. That's another fragment of the exam. Like that would be like if I was your piano teacher and you had to like play, you know, the Beethoven's Moonlight Sonata, if you like submitted the performance to me one note a day, like that doesn't make any sense. You got to give me the piece, right? So, and I'm not trying to say critically, but if you're going to do exam corrections, if you want more points back on problem 2, you have to give me a clean, new, complete version of problem 2 that I can read on its own. And yes, I also want a stapled copy of your original so I can see where I took off points and what I'm looking at. But that's like but you have to redo the whole thing. And you can get whatever help you want, but don't wait for a partner or anything like that on exam corrections. And it is true. And you know, just because you do corrections doesn't mean you get all the points back. I mean, you might still have errors. Now, I'll also say modify because this came up in the other. I'm not trying to look to now punish you for things that I missed the first time. If I literally accepted something fully the first time and give you full credit, it's true that it would not be proper for me now on your second version to suddenly take off points that I didn't before. Even if it was my bad that I missed them before, that's my bad. I don't mean to do that to anybody. So if there's any case where that happened, you can show me and then I will give you the points back. But you can't just correct the things that were missing before. That's not a redo. And let me reemphasize a place that people keep losing points stuff is you have to present what the question is at the beginning of every question. You have to present it in a way that on the one hand makes the question totally clear so I know what I'm reading, but on the other hand cannot just be cutting and pasting or verbatim repeating my original words. That's not acceptable because that does not show that you understand the question. That shows that I understand the question. Okay, that's exam corrections. I will still totally take them, but I will grade them according to that standard that I just said. And what happens is, let's say if you, I mean, just to people that got them back, I think it's clear to the people who got it back, but like if you got a 91 on the original exam and then you lost like 7 points, or I mean, like 9 points throughout, but then you redid everything and you got all the points back. Like if on your test corrections, I wrote 100, what that actually means is, yes, I'm putting in the book a 91 and 100, and they'll average out, and you will have a 96, like 95 and a half, but a 96. Like, in other words, you will get back half of every point that you do, if that makes sense. That's the exam corrections. And if I made a mistake on it, show me privately and we'll work it out. But the other assignment is the one where you have to have a partner and help or be helped. And I still will take that as well. And for some of you, you're waiting for me to tell you who your partner is. And I'm sorry I took so long, but I'm actually almost ready with that. And I will tell you next class. And you're certainly not going to be marked late or anything. But if you're not in that category, if you're not someone who's waiting for me to tell you who your partner is, then that means either you already know and you're doing it, like I've already approved it and you're doing it, or you've done it, or it means you haven't even given me a plan yet. Like that weird all this is optional, but it is all for points. This optional assignment of plan, present, partner up, whatever it's called. First, there was a 35-point portal where you would propose the plan to me. And it could be as vague as, I need help with homework 2. I need a partner to help me. Or it could be like, I rock at everything and I really love, I could help anybody with anything. Please set me up with a partner. Or you could say, I'd love to help someone with homework 3, but like, give me some sense of direction or say what you need, and then I'll partner you up. But if you don't give me the plan, and I'll give you 35 points for just telling me that. Like literally some people just wrote, I need help. I'll take whatever help I can get. Please partner me up with anybody and I'll take help on any of these. Like that's totally open-ended, but at least it tells me what I can and cannot do with you. And you get 35 points for that. But you got to do that before I'm going to accept or look at the 75-point thing, you know, where you actually do it. So this is a very long way of saying with that assignment where you partner up, you have to give me a plan first. And that does not involve the exam. That has nothing to do. It happened because of the exam. Like I'm trying to give more, but that does not, That's partnering up to redo a homework problem, like, or yeah, a homework problem from homework 1 or homework 2 or homework 3 or homework 4, sort of, not the exam. So it's two different things, please. And if there's any further confusion about this, like, again, private chat me or whatever, but they're both still totally acceptable, but that's what they are. I mean, they're both still, yeah, I will still totally accept them, but that's what they are. I mean, and maybe I sound critical because maybe I do feel like I was a little surprised that there's still confusion on that, but I'll hold it personally to anybody. So if anybody asked the question now, I would not be defensive or angry about it. Okay. So. Oh yeah. Okay. And also, okay. So on that, so I'm okay. Private chat. The game assignments, I will absolutely still take them. Yes. Like I mean, they are all like due at certain times to be organized. Like I want you to be able to look clear. Like say there were a couple of weeks you didn't do one of the game class participation things. Yes, I want you to, they're all dated and everything so that you can look back and be like, oh yeah, I didn't submit anything for last Monday. And then you can think, okay, what happened last Monday? Maybe ideally you look at your class notes or my class notes from Monday, or God forbid, maybe the video, and you say to yourself, oh yeah, what happened that day? Oh yeah, that was the day where I didn't do anything. I just said hello, but I did say hello. So you tell me that. Or you're like, oh, that was the day I actually, yeah, he was freaking out about the exam, blah, blah, or about the diagram. And I told him that he didn't attach the diagram to his freaking post. Like, yeah, you totally can still turn those in. And I would love it if you did, but make them accurate. Like, and I guess I want to say something about the game thing now that I think I'm caught up on turning them back to people. You know, in some ways, I'm really happy with that. I mean, some of you have really understood what the purpose of that game thing is and have really taken advantage of it, by which I mean, if you understand what I'm looking for in that daily game assignment thing, it's, yeah, ideally you do it right after class or like that night, just because it's easiest and freshest to do it that way. But whenever you do it, if you get what I'm looking for, it only should take like a minute. It's literally like a minute of self-reflection. It's like a minute of just like forcing yourself to sit down and be like, what the heck just happened in class? And what did I have to do with it? It's just almost a moment of forcing, I mean, it's a moment, it's an opportunity to just like reconnect yourself to the material and to the class and to be sort of accountable for that. It really should only take a minute, but it should be honest. Like, so a lot of you are honestly frequently telling me, I didn't do anything. I just said hello today and I just listened. Okay, that's cool. That's honest. And hello counts. If you said hello, that counts and you're getting 50 points. It's not that I'm giving you 50 points for saying hello, like that's a little ridiculous, but I'm kind of giving you 50 points for having gone through the moment of actually connecting with class and reflecting and being accountable to it. What I'm starting, some of you may have noticed on some of them, I'm starting to give like 49 points, 48 points, 47 points. Still, it's still a lot of points, but just to make a point on some of them, I'm starting to diminish how many points out of 50 I'm giving to alert you to the fact that I think there's something maybe inauthentic or misguided about the way you're handling that. Some of you, like, it just only should take a moment, but it should be a moment of honest self-reflection. This is a delicate thing for me to say, but if you already have a template worked out, like if you already have like a Word document where it just says something like, I don't want to call anybody, if it just says something like, okay, this is nobody in particular. So, but if you have something that's already worked out, that's something like, I loved everything we did in class today. And I said hello and I asked a question, right? And you have that already written out and you just like automatically submit that to me every time. Okay, first of all, I'm not an idiot. Like I see that that's what you're doing. I actually read these things somewhat carefully because they are easy to read and they're kind of fun to read when they're done. So if you're literally giving me the same template every time, I absolutely do notice that. And I'm absolutely a little bit like unimpressed. Like, don't do that. You can honestly just tell me that you didn't do it, that you only said hello that day. And for that honest moment of self-reflection, I'll give you 50 points. But if you're, as a template, generically writing, I loved everything in class today, or I asked a question, like that's not, you can't say I asked a question, or you can't say I answered a question, because I have no idea, like what question? Like, you know, really, do you not remember? Or some people are saying things like, I might have said hello or something. Like, what do you mean you might have said hello? Did you say hello or not? You can honestly tell me that you didn't. And there are cases where I get these things and people say, I just listened today because like my dog is sick. Okay. Like, okay, I can, you know, and as long as I'm not getting that every time, I can deal. But don't just automatically tell me that you liked everything or that you asked a question and write that every time, because that's not sincere. That's like, that kind of misses the whole point, and it also kind of insults my intelligence, right? So yes, so long way of saying, I mean, maybe I'm all full of fire and brimstone today because I did do a lot of grading this weekend, and those little moments, I really get to know you people through those little moments. It really does help me understand where you are and give you the benefit of the doubt if you're on a grading borderline, right? But it can also help me in the wrong way. If you're just giving me a template every time, or then like that does not put a great taste in my mouth. So please don't, I guess. But yes, you totally can still say, turn them in, totally, and just to be honest about it. And again, quite frankly, like if you want to turn one in from 3 weeks ago, totally cool. But maybe watch the video or something. Like maybe remind yourself, act, because that's the other secret purpose of this. It kind of like forces us to know what's going on in class, which is like hard otherwise with Zoom. Okay, so there's that. So now, all right. Yeah, okay, so I'm looking in the chat and I just, wait, okay. No, and I appreciate this. Okay, I'm catching up in the chat. Give me a moment. And I know I sound like I'm yelling. I'm not, I am a little bit yelling because I guess in that one little area, I feel like it's a very generous assignment and I don't really want to be taken advantage of, but I also think it's just easier than some of you people think. And I think, but anyway, let me just read the chat for a second. Hold on. Right. Okay, so yeah, you totally can. Okay, cool. I appreciate, okay, thank you. Oh, yeah, okay. Right. No. And no. And look, we all have to rush right after. I mean, I have a big class right after this too. I totally get that everybody has to rush right after class. But part of the, and that's why I don't want to make this some big like journal entry or something. I totally get that people have to rush. And I also get that like literally sitting and rewatching these entire classes on YouTube just so you can like, you know, that's a bit much. But if you understand how little I'm asking for, like literally you could just jot like, or I look, okay, what some people are doing that really does work for me. And again, I don't want to I don't want to waste anybody's time. But the weird thing is that it turns out that this silly gimmicky game assignment, it's turned out, I mean, the people that are doing it right, like it's turned out to help so much. Like I made it up for Zoom, but I'm totally going to do this if we ever get back to real life, because it's actually turned out to be such a good way for me to get to know each of you as an individual, which is to your benefit, right? That's what you want to be. I mean, sometimes maybe you think it's not because you want to hide because or something, but you always want to be, no, I mean, I think you should like be known, and you want it to be known that you've been present, and it's very hard to have your presence known, you know, especially if you're somewhat quiet or whatever. Like I don't just want to reward aggressive cave people in this class. But what I'm getting at is this: what some people do is just the minute they put something in the chat, anything, like even if I just ask like, oh, did you get the image, folks, and then someone like writes yes, they just screenshot it, right? And even that is not only good, but it's a reminder to that even that act, it's just like taking notes. Half the reason we take notes in a class is not just so that we can look at our notes later. The reason we take, I mean, we, all of us, one of the reasons to take notes is the act of moving your pen and writing things down helps cement things in your brain so that you don't even have to look later as much. And it's the same thing here. If you even just take a moment and screenshot where you say yes to some little thing I said, first of all, there's a huge likelihood that then when you go back and look at that screenshot, it will jog your memory, be like, oh yeah, that's when he asked if he had like posted the image. Or if you think that's not going to happen, like just take the screenshot and just like on, you know, next to you, like while you're taking notes or in your notes for that day, just write like the word down, like screenshot equals image or something. Now I am assuming you're taking notes. You know, if you're not taking notes, I think that's an issue. And maybe that's what this is like raising. But And by the way, some people have even just like taken a shot of their notes that day and sent it to me. Totally great. Totally great. You're just trying to remind yourself and me of your connection or engagement to the room. And so I totally get that, like, you might not remember 2 days later, and I don't really want you to like replay the whole video, but if one or two words doesn't jog your memory or make, then then maybe you do need to watch the video, whoever you are. But like, no, a lot of people just screenshot the chat, and some people go through the effort of sort of blocking out everybody else's names and circling theirs. That's nice. That's helpful. You don't necessarily have to do it, but certainly if you just screenshot, yes, I do want to know, what were you saying yes to? And I think that if you literally cannot remember that at all and can't even take one moment to write down the word, then I'm not quite sure what your note-taking process is all about. Like, especially given how much time I spend saying crap that nobody wants to hear, like right now. Like, all right, so I hope this helps at all. But yes, I will accept them. I will accept them. I'll accept them back from February, especially if they're at all accurate or honest. Okay. Well, no, right. Of course. Look, it's very hard to keep up. I'm reading the chats. And I'm trying not to call anybody up. Yeah, like, of course, people come home tired from work, and of course it's very hard to keep up with school. And I have a hard time. I didn't get back your exams like right away, blah, blah. But, most classes do have homework and responsibility. Like, there are things we're supposed to do for a class outside the class. And not to be rude, but I kind of feel like what I'm asking is much more minor than like a whole problem set or something. Like, I kind of haven't asked for big problem sets in a while. So maybe what people don't understand is that you don't have to do it right away. You could do it 2 days later, but yes, it also becomes harder to do 2 days later. So that's just the balancing that you all have to do. But again, like, even if you just like flip through the notes, that the PDF that I give you every time, or the video, whatever, I don't know. But yes, it's all very hard. And I'm not saying this sarcastically, it's very hard. This whole world is very hard right now, and I hate it. And I hate it for me, and I hate it for you. But I feel like this is one way that, like, I feel like it could make it easier, not harder. I feel it's meant to be easier than like regular homework. But no, and it's all optional. The other thing is, there are definitely those of us, and I would have been one of these people back in the day. There are those of us who, when the rubber hits the road, like, we'll study for a big exam, and we'll get down with the big exam, and we'll rock it. And then the big final exam, and like under pressure, we could do that. But to the day-to-day continuity is not our thing. And we'd rather just do things in big bursts. And if you're that kind of person, which I would have had a hard time with this as a student. I was not good with the day-to-day continuity or the organization. Plus, I would have thought it was very cheesy, and I would have thought it was like very cheesy. And I would have been like, I don't need that crap. Like, let me just do the exams and don't bother me. And I totally respect that. I think that's easier said than done. But if you're a person who's just going to rock the 2 exams and don't want to bother with all this nonsense, my hat is off to you. And as long as you rock the 2 exams, you have your A, and we're all good to go. Like, none of this has to be done by anybody. But if you're at all concerned about the exams or having trouble with the exam, I feel like this is a good cushion that you might want to consider. But okay. But yes, this is all very hard. I hate this. I mean, this meaning like learning and teaching this way. It's nonsense. And as I might have mentioned, 90% of John Jay classes next semester are still going to be like this. Like, and especially for scientists, it's terrible. But I'm okay. So I am more sympathetic than anything else, but also apparently there's been confusion about this. So I'm just trying to clarify. The one thing is, I don't want anybody to ever feel like it's too late. They have already screwed up their whole life or this whole. My one message is no. Even if I sound all jerky right now, it's because the worst thing anybody could do is actually just like give up on this because they think I've given up on them. That would be a failure on my part. Like, it should not feel like it's too late for any of you. And I'm not writing you off, and you shouldn't write the course off, or at least your grade off. Like, because that, I think, is vastly inappropriate in the context of COVID. Like, we're all struggling. So let's not give up on ourselves. Let's just try to get through it. Okay. Oh, okay, cool. All right. Okay, cool. I think okay. No, I appreciate it. No, and I mean, look, and again, I mean, not to get too personal, although I'm happy to, if you guys want to, there have been other classes where all of a sudden we ended up talking about how to get into medical school for 45 minutes. And if that helps people, like, I'll do that. Cause I also know that all of your advising resources are like blown to the sky. Well, not that they were ever that good when you were at John Jay, frankly, but I mean, at least in our department, but like, whatever resources you had or whatever, support systems you all had are all like smashed to smithereens as far as I can tell right now. And again, not to be too personal, but I have two sons and they're both totally flailing under these conditions, right? And obviously I care about school. I'm watching them plummet under this. It's terrible. And I don't hold them responsible and I don't hold their teachers responsible. I kind of hold their teachers responsible, but I kind of hate their teachers right now. But no, it's COVID. Like, I mean, this is not what school is supposed to be about. And anybody who thinks that school is about this, anybody who thinks that school is like a document exchange and that there shouldn't be any issue, whether we're there in a human room with you or not, does not understand teaching or learning. Like, this is a poor substitute for school, but we're just trying to make it as livable as we, meaning I, just want to make it as livable as possible. But it sucks for everybody. Okay. Actually, okay, quick. My new thing that I say when I walk into stores and stuff now, like with the mask and everything, my new or like when I walk into the DMV, which is like a nightmare now in COVID, what I've actually come to conclude about COVID, I really think this is that in a way, it's become the grand separator or the grand, oh God, wait. Oh, okay. Sorry. And of course, I'm way off the topic now. I apologize. That doesn't help anybody. But what I think about COVID in a way right now is it's kind of like the grand unhomogenizer. They like milk is homogenized, right? Meaning that it's the same all the way throughout the carton. Like any cubic centimeter of milk that you pull from the bottom of the carton should be indistinguishable from any cubic centimeter or milliliter of milk that you pull from the top of the carton. That's what homogenized is supposed to mean, that it's all homogenous, it's all the same, right? I think I think that COVID is the grand unhomogenizer, the grand heterogenizer of people, in that anybody who is at all like I'm not talking about students and teachers now, just like people in the world. I feel like what's happening in COVID is if you're at all a decent person or at all a concerned for your fellow person kind of person, or at all compassionate or forgiving or sympathetic, COVID has forced those people like you to be even more sympathetic and more forgiving. Like, the good people out there are getting like super good in a way and like killing themselves to help others and stuff like that. But if you are already inclined towards selfishness, and again, I don't mean you guys, I don't mean students, I just mean like people in stores or in bureaucracies and stuff. I feel like the people that were already at all inclined to be selfish or lazy or to cut corners or just to be cold-hearted to their fellow people, I feel like, whoa, COVID's given them an opportunity to be that much more cold-hearted and that much more ruthless and that much more self-interested and like piggish. And then the nice people are being forced to pick up the slack and I'm not putting myself in either. I can be in either category at any time, but like, to me, COVID is just like separate. It's like creating like class warfare, not just between races and economics, but between like different spiritual categories of people. And I just would rather us all in physics be on the good side, not the bad side, if that makes any sense. But here I am wasting everybody's time talking about it. So I'm going to take a breath. I'm going to move back to the wave equation. You can still stop me with, especially since I just like dropped all this on you. Feel free to still ask questions about whatever, but I'm going to pause for a second and like get back to the wave equation here, or get my brain back to the wave equation. Right. Okay. Yes, actually, Paul. Okay. Okay. All right. So the big thing in black Oh, wait, pardon me. Okay, I am looking at chat. Hold on one second. Okay. Okay. The wave equation. We spent 2 days on it, on just deriving it. Why? Why is it that big of a deal? Like, why? Not only is it that big of a deal, but why is it worth spending this much time proving it? Like, why don't I just tell it to you and assume that you'll accept it? Because I figure you would accept it if I just told it to you. Well, okay. First thing is, it's a very long proof and it's kind of a messy proof. It is a very real proof. It is a much more real, kind of historical and hard proof than probably any other proof we've done thus far. The first time I ever saw it, it took me a very long time to understand it. I mean, I'm giving you my version, I've broken it down, but the first time I was exposed to it, I had no idea what was going on. It really bothered me. And there were a lot of moves made in it that I had never seen before. And it turns out, and it's kind of messy too, it turns out part of why is it's real. Like, it is from Newton. It's not just made for textbooks. It's not a proof that's designed, for people to explain things to other people. It is actually a discovery, and a bit of a messy one at that. So in some ways, it's like welcome to real physics. And I think it's worth you seeing it for that reason. But also, the thing about the derivation of the wave equation is that we grind through all these math steps and everything, and then we get this big crazy math conclusion at the end, which of course I want to analyze now. But lest we get lost in the mathematical trees, let's look at the forest for a second. What this proof means as a big picture is that you can walk up to an everyday macroscopic classical particular, i.e., like particle, like tangible, massive, touchable, concrete object like a piece of string, and you can apply an actual real macroscopic classical force to that string, like you can pluck it with your fingers, right? And then we can apply good old-fashioned classical macroscopic mechanical laws of physics, specifically Newton's second law of motion. We can apply old laws of physics to a typical old regular situation of you touching a piece of string, and then turn the mathematical crank, and what we see come out of the math and of the derivation and of the string is this non-thingy, this non-particular, non-classical, non-macroscopic, non-tangible, non-massive motion, i.e. a pulse, right? Like, the point of the proof is to show that motions of abstract, almost ethereal, like intangible, invisible, indistinguishable items such as wave pulses emerge as a matter of logical necessity from old regular everyday laws of physics being applied to old regular everyday objects. In other words, I'm from here on in going to believe in the motion of wave pulses or waves. I'm going to believe in them and do physics on them and predict their motion, like analyze their motion, believe in their motion, even though they're intangible and indistinguishable and immaterial and unmasked and all that. I'm going to believe in them and treat them just as legitimately and strongly as I treat anything else in physics, as I treat tennis balls or planets or electron or whatever, because I did not have to invent one new law of physics at all for them. Like they are the result of old laws of physics being applied to old regular everyday objects. In other words, unthingy motions exist in the scientific measurable world of space and time because we can prove that they exist from old methods and old laws. We don't have to invent new laws called like wave laws or electricity law or something like that. That's a very powerful recognition. Like it's why every abstract thing that's ever going to happen in physics from here on, whether it's this course or any course you might take, even especially like say PChem or something like, or in other words, quantum mechanics, all the weird things that you've ever heard about in physics that don't like seem to exist in a normal, tangible way, they don't require a new set of beliefs in order to believe in. They follow logically from our old set of beliefs. That's important, I think. I mean, it's sort of a pride and joy of physics that we can deal with the intangibles through our tangible methods of measurement and analysis. So that's one reason that the proof is really important, that it shows that we didn't just derive the wave equation, we derived it from Newton's second law. That's a big accomplishment on Newton's part and on our part. Now, so that's like why we care. And pardon me for one more second. I'm sorry. Okay. All right. Now, what does it mean, the wave equation? I mean, it is a second order partial differential equation. If you understand even the slightest piece of it, you should be proud of yourself. Like, it's a lot. But hopefully you do understand the slightest piece of it, and hopefully I'm going to help you understand more of it now. So let's look at it. And I know I'm going to slightly repeat and I know it's already like 4 o'clock and we have 20 minutes, but I'm going to slightly repeat something I said last Wednesday just to put it in perspective, because it is a mouthful, the wave equation. So, all right. First of all, so I'm looking again at this black thing on the top of the page. Partial 2y over partial t squared, partial square y over partial t squared equals t over mu times partial 2y over partial x squared. Like a lot of symbols there that are sort of new to some of us. But let's chunk it first. Let's stand back. Recognize that on the left side of the equation is some kind of thing. Like, yes, it happens to be a second derivative. It happens to be the second partial derivative of y with respect to t. But don't even bog down in that for a moment. Just understand that the left side is some kind of, it's a derivative, and a derivative is a function. So the left side could just be its own variable. You could just think of it as g of t, or you could just think of it as a y or whatever. It's a thing that you could chart on the y-axis of some graph. Similarly, on the right-hand side of the equation, so this chunk here is a chunk. It may be an intimidating chunk, but it's a chunk. Just like a derivative is a thing, that's a thing. And what's linking the two of them in parentheses is some kind of constant over a constant. So i.e. a constant. So first and foremost, if this is not already clear, let me emphasize that one of the things that's elegant about this wave equation, one thing that's shocking, is its simplicity. Even though there's a lot of complex symbols in it, this equation is, in effect, a y equals mx plus b equation where the b is 0. Like, this is literally a y equals mxb, a y equals mx situation. You can make, like you see down here in the red, you could make two axes where on the independent axis was d2y dx squared. Like, and again, even if you're not totally comfortable that you get what that is yet, it's a thing. It's a variable in itself. It's a variable. You could put that on the x-axis. You could put the other derivative on the y-axis. And what the wave equation is saying is that the left-hand side is linearly dependent on the right-hand side, or is, in other words, that derivative on the left is the derivative on the left is equal to a constant times the derivative on the right. In other words, the derivative on the left, and again, who cares what a derivative is for the moment? It's a thing. So the thing on the left is directly proportional to the thing on the right. And the y-intercept is 0. So this is just a line. We're saying that something is linearly related to something else. So at some level, this equation is as simple, like once you feel comfortable with derivatives and stuff, and by the way, I think many of you do, and then if you're comfortable with derivatives, I think many of you are comfortable with second derivatives. And so now the only sort of new piece in all this is that they're partial derivatives. But what we are ultimately saying is that some kind of partial second derivative is linearly dependent on some other kind of partial second derivative. And that means that this equation is just as simple and as powerful as distance equals rate times time, or F net equals ma, or anything else like this. It is just a linear equation. That's the first thing. Now, what is linear with respect to what? Like, what are all these derivatives doing? Well, let's remind ourselves, and I started saying this last time, but I don't think I said it thoroughly. Like, let's remember, let's go back to simple harmonic oscillation, like to Hooke's law, right? Which is now where I am down here. So let's go back to the beginning of the semester in our minds and picture like a mass on a spring, only picture the mass on a spring. Picture, like in our very first problem set, we pictured a mass on a spring that was free to move horizontally. So we talked about x and F equals negative kx and x equals negative km over d2x, blah, blah, blah. But also in your very first lab, we happen to have had the spring on its side. And instead of talking about x, we were talking about y. There's no difference between a vertical spring or a horizontal spring. Like, there literally is no difference. You might say, what doesn't gravity affect the vertical spring? Well, one of the lessons of lab number 1 was supposed to be, and just to jog your memory, that sure, if you take a spring and you turn it on its side, gravity does affect it somehow, but here's how it affects it. It changes the equilibrium. Like, if you turn a spring on its side, that means that the mass will fall down a little bit because it has weight. It'll fall to a new equilibrium position, one that is like kx over, that is mg over k below where it otherwise would have been. Okay, but then that's the new equilibrium position, and now everything is going to happen around that equilibrium position just like it would have on its side. That's actually supposed to be one of the insights of lab number 1. So a vertical spring is no different from a horizontal spring. Once it's in action, we don't even have to worry about gravity anymore at all, as you did not in lab 1. So let's picture a vertical spring. For a vertical spring where we're tracking y instead of x, and I'm doing that just so we can like make a parallel here. If we compare to a vertical spring, I'm reminding us of how Hooke's law, is written mathematically for a vertical spring. For a vertical spring, what we say is, aha, we got this mass that's going to move up and down, oscillate around some equilibrium position. It's going to move through the y-axis. And at any given point, if we asked at what rate is it accelerating back toward the equilibrium position, if we ask that at any moment, the answer is given by Hooke's law, is given by this differential equation. The answer is this mass is always accelerating back home, right? If it's above the equilibrium position, it's accelerating down. If it's below the equilibrium position, it's accelerating up. And of course, then it's just going to keep moving through the equilibrium position, but it's always accelerating toward the equilibrium position. And what Hooke's law says is the rate at which it's accelerating back home is directly proportional to how far it is displaced from home. The farther away it is from equilibrium, the faster it'll accelerate back to equilibrium. And in that simple, direct proportional way. There's a negative sign just to make it clear that it always accelerates toward it, not away from it. And the k over m is ultimately just a constant, right? Just a slope of that straight line graph, but it's a constant that is determined by the material properties of the system, like the stiffness of the spring and the mass of the mass, right? So with Hooke's law, with all oscillator, just to remind you, just to make a contrast here or make a parallel, with Hooke's law, you have a zero-dimensional point, like the center of mass of some object, and it's trying and it wishes to be back home at the zero-dimensional location that we call equilibrium, right? Remember, a line is one-dimensional, a plane or a surface is two-dimensional, or put another way, what is a dimension? A dimension is a line. A dimension is an axis. If you have one line, you have one dimension. If you have two axes, you have a two-dimensional surface or a plane. If you have three dimensions, you have a solid, like a cube or a sphere. If you have no dimensions at all, that's what a point is. A point like is smaller than a line. It's somewhere in space, but it doesn't even consist of a full dimension. So points are zero-dimensional, lines are one-dimensional, et cetera, et cetera. So in the case of Hooke's law, you have the zero-dimensional point at the center of mass of the object. It is displaced. It is far away. It is displaced along some one-dimensional line from its home spot, its home point, its zero-dimensional home that we call equilibrium. And what we say is the farther away it is from home, the faster it accelerates back home. That's what Hooke's law says. That's what oscillation is. Now, go up to the wave equation. Look up at the wave equation. Well, first, the left side of the wave equation is exactly the same as the left side of Hooke's law, only I'm now using these new symbols, these backward sixes instead of D's, only because I'm recognizing now that if we're going to talk about I'm recognizing now that if we talk about a wave pulse, we're not just talking about something whose Y position depends on the clock. We're now talking about something like a long string stretched between two lab partners or two nails and two walls. And we're now saying that the height of the string at any moment not only depends on what moment it is, but also depends on where we're looking horizontally in the string. So we now have a function of two variables. So in recognition of that, every time we take a derivative, we're going to take derivatives with respect to one independent variable at a time. We call those partial derivatives. So we've switched our symbol from D to that backward six looking thing, which we call partial. That's in recognition of what's probably going to happen on the right side of the equation. But, technically speaking, I could have made the D's down here in Hooke's law backward sixes too. In other words, I'm saying the left-hand side of the wave equation is literally identical to the left-hand side of Hooke's law. The left-hand side of the wave equation is literally is the second derivative of position with respect to time. And that is what we did call, and we're still going to call acceleration. Like this left side is acceleration. Like the whole left side, that whole chunk means acceleration. What kind of acceleration? The acceleration in the Y, along the Y-axis of the little bit of string that's been displaced from the rest of the string. So to the left side is acceleration. Well, that's not really legible, but that's true. Now, and that's just like Hooke's law. So we look at a piece of string, we're like, hey, at what rate? Oh, that little string looks displaced from the, that little bump in the string that we just made. It looks displaced from the flat line. Oh, I wonder at what rate it's going to accelerate back to the flat line. The left side says, oh, I'll tell you what rate it's going to accelerate. Let's look over to the right side. Well, first of all, it's going to be some constant, some set of constants times something, just like Hooke's law. Hooke's law happens to have a negative sign. This one happens not. That's okay. Both -1 and +1 are both constants. That doesn't change the concept here. Furthermore, in Hooke's law, it's K over M. Here, it's T over mu. T stands for tension. And by the way, this is where you do have to be paying attention in class. Like we have a lot of T's floating around. We have a lot of K's floating around. And we have mu's. Like if you just tune in right now, it's possible that you would think that by mu, I mean mu from physics 1, like coefficient of friction. That's not what I mean here. The mu, so T here stands for tension in the string. Mu stands for density of the string, linear density, mass per unit length. Why am I saying that? Because just like K and M, T and mu are mere material properties of our system. There's a certain amount of tension in the string. And as we took pains to tell ourselves 2 days ago, whatever that tension is in the string is in magnitude the same over here as it is over there, over there. The string has one amount of tension throughout it. And mu is the density of the string. We're assuming the density is a constant, that it's not, the string is not thicker over here than it is over there. It's a certain amount of thickness throughout. So T over mu, and please actually write this, I don't have room on this page without freaking everybody out, but T and mu are both parameters, just like K and M are parameters. That means, yeah, they're constant, but why are they constant? Not because they're Planck's constant or something like that, and not because they're like the number pi. They're not universal constants. They're constants because they are constant material properties of the string. They're parameters, T and mu. So far, I'm saying this is just like Hooke's law, reading across left, right. Now, even with only 6 minutes left, the big deal here is, what the heck is this? Like, all of a sudden now the wave equation gets more complicated than Hooke's law. Hooke's law said the rate at which a mass accelerates back to equilibrium is directly proportional to how far away the mass is from equilibrium. Equilibrium is a spot, a zero-dimensional location. The mass is also a spot, a zero-dimensional mass point, and it is displaced by some length along some vertical axis, some line. That was the deal with Hooke's law. Here, it doesn't say y on the right-hand side. It says partial 2y, partial x2. What's that all about? What that is, and I'm really tempted to ask you all, but I know we're running out of time, so I'm not going to. Remember, go back to what you learned in calculus, like calculus 1. Remember that when you're first doing graphs and functions in calculus, like you have y equals f of x. You put y on this axis, you put x there. And no one's saying anything about time or anything until we get into physics. But like in a math class, you just have a pure function like vertical position as a function of horizontal position. Like you have rise and you have run, right? Y and x. And when you're doing graphs like that in a math class at first, you find that you make a graph of whatever function you want, and visually, graphically, the slope of that graph at some point is what we call the derivative. The derivative measures how steep a graph is at a point, how steep a function, a curve is at a certain point. First derivative measures slope, particularly slope at a point. Second derivative, please stay with me. I know we've got 4 minutes. Second derivative is like slope of the slope, right? It's like rate of change of rate of change. What does that mean visually or graphically? Well, that's like not just how steep the graph is, not just how quickly it's rising, but how quickly the rise is rising, which in one way of putting it is like how bendy the curve is, or put another way, the actual proper word that you learned in math. If first derivative is slope, second derivative, please remember, is concavity. Yes, I hope that's familiar to people. Remember, you talk about concave up, concave down. In other words, first derivative measures just how steep something is, but second derivative measures how bowl-like something is. What does that even mean in real terms? Well, like picture like a parabola, like a big, like y equals x squared, big bowl, right? If you think about it, if you look at first derivatives of a parabola, they're changing every moment. Like just like an accelerating object is changing its velocity every moment. Like a parabola going like this is getting steeper and steeper and steeper as we go up. But its concavity, the extent to which it's like a bowl or not like a bowl, well, that's not getting more and more dramatic as it goes up. It's like a bowl here and it's like a bowl there. The whole point of second derivative is that it's the slope of the slope. Just because there is a slope doesn't mean the slope is changing, right? Or just because the slope is changing doesn't mean that the change is changing. In other words, there's a difference between slope and concavity. Concavity is how bowl-like or how unflat a curve is. So I'm saying this. So I'm saying they're both, we have two second derivatives here, and I know there's 2 minutes. There's I have a second derivative on the left side of the wave equation. I have a second derivative on the right. It might just look like one big circle, like we're just saying second derivative is directly proportional to second derivative, like duh, like isn't everything proportional to itself? But that's not what we're saying here. We're saying second derivative with respect to time is directly proportional to second derivative with respect to space, meaning in English, and this is like the lot, you please try to copy this down or get this notes later. What I'm saying in English is that at any given moment and at any given position in a wave pulse, the rate at which, and okay, this is the thing. If you look at that little bump in the string that we just, because we plucked the string, we're saying if we look at that little section, the rate at which it accelerates back home is directly proportional to the concavity in the string at that point. It's just like what we were saying with Hooke's law, but it's extrapolated now or blown up to a higher dimension, meaning that with Hooke's law, with the spring, home was a point, was a equilibrium position of 0 dimensions. And we were far away from it because we were far away along some line of 1 dimension, we meaning some mass point of 0 dimensions. So the farther away we were from this home point, the faster we would accelerate back. What this is saying now, and forgive me if I got like 1 more minute, or if you have to go, but I'm just about, this is the last page, but here with the wave equation, what we're saying is home is no longer a point. Equilibrium is not a 0 dimensional position. Home, equilibrium, is a full line. It's an axis. And I don't care where that axis is. No one's saying the string has to be here or has to be here or has to be here. The point is that the string, if no one's perturbing it, is flat. It's horizontal. And when we bend a little piece of the string, we're not moving the string to a new place. Like most of the string is still in the same place. We're changing the shape of the string. We're making the string more concave. What we're saying here now is if you pick that little point that you plucked and you let it go, the rate at which that little piece will accelerate back down to the home line is directly proportional to how unflat the string is right there. The rate at which a little bump of string will accelerate back to the horizontal axis is directly proportional to how not horizontal the string is at that point. Acceleration is directly proportional to concavity, is what we're saying. That's what it means to be a wave pulse. And here, and I know I'm 1 minute over here, but the real kicker that's mind-blowing to me. So it's like Hooke's law, but in 2 dimensions of space at the same time rather than 1. And furthermore, if you can sort of follow what I'm saying, all this is just saying that that little bit that we plucked, that little bit that we're picturing that's now deformed, it's going to accelerate back at a rate that is directly proportional to the extent to which it's deformed. That's what we're saying. But remember that the little piece that we've analyzed, that we did this whole proof, was an arbitrary segment that we just picked at random. And as soon as it starts going back and starts flattening out, like the string has to go somewhere. It's still one big length of string. So of course, the next bit, like the slack, is going to be picked up over here. There's going to be a bump over here now. So what we're actually saying is that this equation, once it's in motion, will be true necessarily for every single point on the string at every single point in time. When anything and everything is obeying this equation, we have wave phenomenon. And whenever we think we see wave phenomenon, that means at every and any single point in space and every and any point in time, this relationship is obtaining. That acceleration back to the home axis is directly proportional to the amount of distortion from that home axis. That's what this is saying. It is Hooke's law in space and time. But I went 2 minutes over, so I have another cut. So if that's sort of clear, if I could get a quick goodbye, then we're done. And sorry, I was yelling before, but I hope so. Goodbye. Are we good? I can't see. Oh, thank you again. I appreciate that. Yeah, thank you. Okay, cool. We'll keep talking about. Thank you. We'll talk about Wednesday. Awesome. And thank you. I appreciate that. IS. Okay. Yes. Bye. Okay. I'm closing because the other class is going to come. Okay.